So hi, everybody. Thanks for joining us tonight for the webinar on machine learning applied to modeling events and information in literary fiction with Matthew Sims. So I'm Drew Pollan. I'm the academic director of MIDS, and I'm really happy to introduce Dr. Matthew Sims, who will be leading this workshop to share his work with us. So Matt's a postdoctoral scholar and lecturer here at the School of Information in our MIDS program. He's taught W207 Applied Machine Learning last term, and he's currently teaching in W266 Natural Language Processing with Deep Learning. His research focuses on developing new natural language processing approaches for understanding narrative. He received a master's degree from Cambridge University and a PhD from the University of Chicago. So today, Matt's going to present for about 40 minutes, and then we'll have some time at the end for questions and answers. Please do feel free to post questions in the chat, and we'll ask Matt to address those questions at the end of the session. Hi, Matt. Thanks so much again for leading this session.
Great. Thanks, Drew. Just going to go ahead and share my screen and get started.
Perfect.
Okay, so the title of this talk is How to Machine Read a Novel. So essentially, I'll be trying to get at what ways we can use NLP to analyze and think about fiction, right? What we can do with NLP that we maybe not be able to do otherwise without the power behind NLP and machine learning. But conversely, also ways in which applying NLP to literature can actually challenge our conceptions of NLP and maybe opening up some new lines of research that we might not have thought about otherwise. Just gonna move this over. Sorry, 1 second. So what does data NLP look like as far as the landscape goes? Lots of news, right? We have news as being kind of the most common thing used in NLP. Social media, you can imagine, also very common. Wikipedia becoming increasingly common. There's other things, and then here at the tail end we have literature represented here by Mark Twain, much less common, right? Not a ton of literary data being used in NLP. That being said, there is a lot of interesting work in the field of computational humanities that works with literature. So this isn't quite NLP, but it has some similarities to it, and a wide range of things. Time in literature, emotions of London as captured by literary text, gender, loudness as a concept, finance, geography, literary diction. So a super wide range and interesting set of different themes and ways of approaching literature. So today I'm presenting two recent projects that have some similarities to computational humanities, but also kind of move more towards NLP. So how do we maybe integrate more traditional NLP with these kind of approaches to literature and thinking about literary text? First, we're talking about event detection. So how do we actually pull out events from literature and identify them? And information propagation and literary social networks. So can we actually capture the ways in which information moves between characters in these literary social networks, which hasn't been really examined previously? So I'm going to start with literary event detection. This is a joint research with John Park and David Baman, and I'm just going to dive in. So worth starting by defining plot, and who else to start with than Aristotle? So Aristotle defines plot as the imitation of the action, the arrangement of the incidents. So today I won't really be focusing so much on the arrangement as I will on the incidents themselves, but with understanding that the incidents are a way of capturing that arrangement, right? They are the first step towards getting to full understanding of plot. It's worth thinking about sort of what else what other approaches have been used for computing plot. They're not a ton, in fact. One interesting early approach, early, I should say 2014, is Jocker's and a novel method for detecting plot, which uses sentiment as a way to capture plot. So here you see Portrait of the Artist as a Young Man by James Joyce. And on the y-axis, we have positive and negative sentiment. And on the x-axis, the percentage of the book that's gone by based on the number of words. You can see here you kind of have the somewhat more rocky, extreme drops in sentiment being smoothed over a bit, but maybe we get a kind of general sense of the direction of how plot might be working in relation to sentiment, right? Highs and lows, a high towards the end, for instance. Similarly, Reagan et al. In 2016 used sentiment again as a way of trying to capture plot, here claiming that they can find 6 basic shapes which pretty much every plot falls into, and then they group different plots of novels and plays into these different groupings. Again, interesting, suggestive research. What are the problems with this? One possible problem you could see is simply that sentiment is arguably more of a proxy for plot as opposed to actual plot itself, right? Certainly sentiment is relevant to plot, but whether it actually is the same thing as plot is a reasonable question to ask. With that in mind, take a look at this XKCD comic, which is, I think, capturing a different way of thinking about plot, right? So here we have things like battles and other events. We have deaths. We have the movements of characters. Right? We have a much more fine-grained sense of what's actually happening in a novel, as opposed to just thinking about sentiment. And so it's with this in mind, kind of, that this current research tries to go forward. Essentially, the larger project of which is only a piece is to try and figure out a structured approach to plot. So today I'm talking about events and event detection, but you can also think about characters, setting, objects, and time. And of course, event detection is necessary for some of these things, such as like event setting coreference and event ordering. Also worth noting that all of these things are in fact pretty traditional NLP tasks. So entity recognition, object detection, these are all things that happen. There's active research in these fields. So I already defined events a little bit, but it's worth stepping back and thinking kind of what's the philosophical tradition of thinking about events. And there's this realist view that carries over across lots of philosophers. This says essentially that events are just things that happen. So everyone from Aristotle to Whitehead and Quine essentially are saying more or less this. More specifically, we can think about events as occurrences that are associated with change. So dropping your watch, or raining outside, or finishing an exam. And we can contrast these to non-events represented by persistent states, which tend not to be associated with change. So facts about the world, like Florence is in Italy, epistemic states, she knows the answer, or ontological states, he is a black belt in judo. Events actually turn out to be a pretty rich field of research in NLP, a lot of work in this area, and different aspects of it. Event trigger detection, so just pulling out and detecting events themselves. Verticality and factuality, to what degree did an event actually happen based on discourse? Is it definitely happened? Was it negated? Was it maybe, did it maybe happen? Temporal grounding, so thinking about how we might think about events in time, and narrative event chains and schemas, which is say, given an event, what are other events that seem to cohere with it to get a whole sort of chain of events, this happened and that happened and so forth. Likewise, decent number of NLP data sets, often just focusing on news and different aspects of the news seen here. Also, sometimes there'll be news plus something else, so blogs, email, discussion forums, etc. The common through line here again being the news. So one might reasonably ask, what about literary events, which have been generally overlooked in NLP? What makes them interesting? What makes them unique? For one thing, the novels tend to be much longer than news articles and blog posts. In fact, novels are roughly two orders of magnitude longer than the average news article. They tend to incorporate figurative language and metaphors and all kinds of difficult things which challenge traditional NLP systems. And we can assume that the distribution of events in a novel is probably pretty different from the distribution of events in the news. So for all these reasons, this seems like something worth thinking about and analyzing further. So with that in mind, we in fact create a data set to do just this. 100 English language books from Project Gutenberg. All these are in the public domain, so all published for 1923, and a nice mix of different kinds of things. On the one hand, canonical works like Moby Dick and Pride and Prejudice, but also genre fiction like Tarzan and the Apes. For our annotations, we just take the first 2,000 words of each text and annotate that for events. So our scheme follows some previous schemes that have been used, but also has some unique aspects to it. We only tag realis events, which I'll talk about more and define what that is, but this is like the light ERE approach. We only tag single word event triggers like ACE and FactBank and PragBank and meantime. We include verbs, adjectives, and nouns as the different parts of speech. And we make no restrictions on the types of events that we tag. So this is in contrast to ACE and ERE approach, which has these 8 categories that it restricts the tagging events to. Events, besides the definition I already gave, there's kind of been a sense of events going back to Wendler's paper from 1957, in which events are broken down into 3 separate categories. Activities, so these are dynamic processes that don't necessarily end explicitly. So he's running to the store, for instance, ongoing thing. Accomplishments, something that has duration, but also a clear, definite end. He ran the race in just under an hour, so it's completed. And finally, achievements, which are occurrences that are essentially instantaneous and have no duration. He arrived at the finish line at 2 p.m. So all of these are things we would include in our event annotations. We also, as I mentioned, just want to capture realis. So realis, when it comes to events, is a way of capturing events that actually occurred, as opposed to things that might have occurred or didn't occur. So we only capture things that were positive actually took place. And there are 4 different ways that we capture this. So first is polarity. So let's talk through polarity. Can be, since a word can be positive polarity or negative polarity. So John walked by Frank and didn't say hello. Here walked is positive. It did happen. Say it's negative, it's been negated. And we would choose positive things as a way to capture realis. Second, tense. Past tense, I walked to the store and will buy some groceries. Buy here is in the future. So we would include past and present things, right? Those things have happened, but future things like buy, we don't know if they are going to happen in fact. So we wouldn't include those as events. Genericity can be specific. I ate a slice of pizza for dinner last night, right? Single event occurring at a certain place and time versus generic, people often eat pizza for dinner, right? There's no specific instance of this that we're pointing to. We're just saying generally this thing can happen. And we're only going to select the specific case to capture realis. And finally, the last category, modality. I walked to the store to buy some groceries. Walked here is asserted, right? This definitely happened. The buying of the groceries may or may not have happened. It's not asserted. We'd only select the asserted case. So those 4 things, aspects of things that are essentially what we're trying to capture to get realis. It's worth looking at some other kinds of modalities. There are lots of different modalities that we wouldn't actually be selecting. So these are all things that are in the irrealis camp, didn't necessarily occur. So beliefs like rumors of my demise have been greatly exaggerated. Hypotheticals, if you leave Florence, it's worth taking the train to Rome. Commands, John was ordered to return the book or face a fine. Threats, am I threatened to release throws if Bezos did not comply? Desires. So all these things, right, they aren't asserted to have definitely happened. They may or may not happen, but we can't say for sure. So these are things we're not selecting. So I've talked about literature and why it might be interesting, but it's also worth talking about why it's difficult and why it might challenge NLP systems. One I was saying is figure events. So here's from Henry James' Turn of the Screw. He had broken a thickness of ice, the formation of many a winter, had his reasons for a long silence. Broken, right? It's unclear exactly whether this breaking actually happened. Is it all in his mind? How would we represent that as an actual instance? And so something like this we wouldn't actually select as a realis event because of the kind of vagueness around it. Similarly, we often get ambiguous assertions like this one from Melville's Moby Dick. Why upon your first voyage as a passenger did you yourself feel such a mystical vibration when first told that you and your ship were now out of sight of land? Right here, Melville is addressing us, or Melville's narrator rather is addressing us, but I personally didn't experience any things. I imagine you probably didn't either. So it's ambiguous whether these things actually happen since they're being referred to us. So again, these are things we wouldn't select. So in all, we end up with 7,800 roughly realis events out of our just over 200,000 tokens in total that we annotate. And our annotated agreement is pretty good. We get an F score of 81 and a Cohen's kappa of 0.813. So decent job in annotations. We can look here at the events with the highest scores in data. If you look on the right side, we have the total count of each event and the event rate. So how often is it actually event when we see it in a text? They may not look like super interesting words, but we can kind of break them down and see general categories. So on the one hand, conversation, movement, perception, and obtainment. So these are kind of the 4 predominant things we see occurring as far as realis events that take place in these narratives. Okay, so getting back to the task itself, right? The real goal here is to take these texts and to figure out, can we detect events, event has occurred. So here, right, 1 is representing the event class and the 0 is representing a non-event class. And so, right, in the Dickens, David Copperfield, we would select closed as being an event and opened as an event. So my father's eyes had closed upon the light of this world 6 months when mine opened on it. Conversely, call me Ishmael, call, we would not consider an event. Right, it's not realis there. We don't know if the calling actually happened. This is just a demand. So we would not select that. And so we try a variety of things to see if we can actually capture these in model form. And so we start with a really naive baseline where we are only selecting verbs events. So every verb is going to be taken as event. And as you can imagine, the recall is very high. Most of these events are in fact verbs, but the precision is very low. Lots of verbs are not events. And overall, the F1 score shows that this is not doing very well. Next, we try a featurized model. So we take the word identity, the part of speech, the left and right context, and their part of speech, the synset, wordnet information, and dependency label and head. So various different features. So we've chosen to seem useful. We also, inspired by Ryder and Frank's approach of looking at their plurals, we see whether or not the noun subject relation as a specific or generic relationship. So in the specific case, right, he just finished the last slice would suggest that it could be a realis instance and hence a proper event that we're looking for. Whereas these generic cases, these bare plurals like people, suggest that it's probably not a realis event. So our featurized model, which we just use L2 regularized risk regression on, does potentially better than just the naive verb approach. Precision goes way up, recall goes down a little bit because we're not just selecting verbs, but overall F1 score does much better. And next we try a range of neural models to really see if we can do this more effectively. And so we take word embeddings learned from Project Gutenberg texts. So these are texts that were relevant to our domain, right, literary texts. And we try everything from just the basic single directional LSTM to more complex architectures like a hybrid bidirectional LSTM with CNN and a subword CNN. So here's the general model. Here's the kind of basic bidirectional LSTM. And again, the goal is to do this in a sequence way where we're just trying to figure out for each word fed in, is it an event or not? So 0 or 1. In this case, everything's a 0. We also try the more complex model. So the CNN plus max pooling of Feng et al. We find it actually doesn't do as well as just the basic bidirectional LSTM. So that's what we end up using. So the bidirectional LSTM with the subword CNN, along with those word embeddings that we trained in Project Gutenberg, does better. Right now, we've increased our precision in recall over our featurized model, and the F1 score goes up. So we're finally getting somewhere. To even make a bigger improvement, as you might expect if you've been following NLP, it's worth trying out BERT, and that's what we do. So we don't actually fine tune on the task. We just take the BERT representations and plug them into our bidirectional LSTM, and we see how we do, just changing our essentially our embeddings from the Gutenberg trained embeddings to BERT embeddings. And substantial change, right? BERT really does make a big difference even without fine tuning. And so here we're getting close to 80% on our F1 score and doing pretty well. And I should say that we did in fact try fine tuning and it only improved the F1 score by 1%. And so to make this kind of easier to run for other people, we just stuck with using the plug-in BERT embeddings as opposed to the fine tuning. Okay, so now we have this model that works pretty well at identifying events. What can we actually do with it? So one application that seems obvious is just measuring the concreteness of novel by looking at the frequency of these events. So you can see in this table on the right that novels like The Quest of the Silver Fleece and The Invisible Man, genre fiction, tends to have lots of events. Roughly 10% of our annotations were events in The Quest of the Silver Fleece. Then as you go down towards the bottom, kind of more high, sort of canonical fiction, high literature, we could say, Moby Dick and Middlemarch have very few events, and the Magnificent Emersons in the 2,000 words we annotated had 0 events. So kind of interesting way to separate things and think about how genre fiction may differ from high literature. You can also look at the distribution of events over time. So here on the x-axis is reader time and y is the count, and each novel has been broken up into different sections. So here we're looking at the first quarter of the novel and then so on and so forth. And we can see that over time, there tend to be more realis events. So beginning not so many, and by the end of these novels, lots of events are occurring. We can also think about prestige. So what are the signals of prestige when we look at these realis events? and how it may differentiate between something like 50 Shades of Grey, so very popular fiction, versus something like Anna Burns's Milkman, which won the Man Booker Prize in 2018. We consider two possible ways of thinking prestige. The first being L.G. Hewitt's approach, so inclusion in the Oxford Dictionary of National Biography, MLA, Stanford Exam List, and second, looking at the approach of Underwood in 2019 of just looking whether these novels are included in elite literary journal reviews. We end up going with the second approach. So we find the 100 authors identified by Underwood with the highest and lowest prestige. We take a sample of these and we run our model on them, right, to identify realist events, and then compare the results to see the frequency in each one. And you can see by this table that indeed there is a difference. There tends to be substantially more realist events in low prestige novels versus high prestige novels, and to the right you can see the confidence interval. It may not seem substantial, but I think it becomes more apparent when we look at these violin plots here. So indeed, low prestige novels tend to have higher event ratios. They tend to have less variance in their event ratios, whereas there's a lot more variance across high prestige and a lot more instances of novels with low event ratios in the high prestige case. So how do we want to interpret this? I think there are a few ways of doing it, but one way of thinking about it is just there's more freedom for high prestige novelists to not have anything happen in their novels, right? So low prestige, there seems to be this pressure to constantly have events occurring, to have kind of the plot moving forward, and more freedom maybe for high prestige novels to kind of not have anything happen, to do kind of more psychological things, or sort of just talk generally about, you know, large scale history or what have you. And so this was an interesting finding to us, and I think it's worth, with this in mind, returning to my original definition of what's plot. So plot on the one hand, as we said with Aristotle, is the imitation of the action, the arrangement of the incidents. But we might also say, as Peter Brooks does, plot is why we read Jaws, but not Henry James, right? Plot is what makes something kind of edge of the seat. As a quick addendum to this, I'm going to briefly talk about inverting plot. This is somewhat more inchoate work, but the question here was, if we take this model, right, this realist model, and invert it, what happens? Which is, say, what happens when we capture events that didn't happen, or might have happened, or could happen in the future, right? All the things we were trying to avoid previously, and particularly looking at birth, marriage, and death in fiction. So again, if you remember, these are the things we were avoiding previously: beliefs, hypotheticals, commands. And these are now the things that we're actually going to be capturing, or trying to capture. And maybe this becomes clear with some examples. So here's marriage in Louisa May Alcott's The Mysterious Key and What It Opened. On the top, we have realist events, and on the bottom, irrealist events. So realist, again, things that actually happened; irrealist events, things that didn't necessarily happen. I'm not going to read through these necessarily, but just read through this one at least. He told no one of his marriage, meaning to surprise his English friends by producing the lovely woman unexpectedly. Accident threw in his way another lovely woman, and he married again. So here we're getting maybe a little bit of sense of plot, right? A realist should be giving us some sense of the plot and what's happening. Also worth noting, right, that these realist events of marriage happen at the beginning and the end of the story. We compare that with irrealist events. So when is she to be married, right? This kind of open question. You vowed you'd win and wed your fair little lady love if you lived. Again, things that aren't necessarily happening. Maybe in a sense, we could think of these as the underlying energy of plot, right? This kind of underside of plot that's kind of giving us some sense of what could happen. Similarly, death in Hawthorne's The Blacktail Romance, which I'm just going to skip over these examples for time's sake. But again, similar thing happening. And so to get a kind of grander sense of what's actually going on here, I applied this now to roughly 7,000 novels, and taking a look at kind of what kind of patterns we see as a result of this. So here on the y-axis is the ratio of real events per slice to the total events across the whole novel. And on the x-axis are slices. So I've sliced up all these 7,000 novels into 20 equal parts and then lined them up. So right, 0 is that first slice, and in the dot, right, every dot we see is representing a slice for that specific category. So the first thing to note, right, is that birth is kind of flat. So what we expect if there was the same amount of events in every single slice of all these novels, we'd kind of be around 0.05, and indeed that's what we see across the board for birth in most cases. Conversely, for marriage and death, we see this kind of bowl shape. So lots of realis events for marriage and death, so things actually happening in terms of marriage and death at the beginning of novels and even more at the end of novels, but less so in the middle of novels. So it kind of drop in these events in the middle. What about, sorry, this is just sort of highlighting that kind of shift at the end in the beginning of these texts. What happens when we look at irrealis events, though? Do we see a different pattern? Indeed, we do. So irrealis events, again, things that didn't necessarily happen or may not happen or didn't happen. So birth is a little bit more wavy, but more or less the same. Marriage, instead of this big dip in the middle, we see it actually comes up in the middle. So more kind of discussion around marriage in the middle, even though marriage isn't actually happening. Sorry. Just gonna reopen this. Okay, marriage is actually happening. And then finally, as far as death, right, we see death consistently increases over the course of a novel, right? So essentially we have death as an underlying energy that consistently grows over the course of these novels and becomes more and more prevalent. We see, right, conversely again, to death dropping in the middle. So summing up, realis events are concrete occurrences, right? These are ways of capturing plot. And conversely, irrealis events we can think of as underlying narrative energies of plot, right? So these things that could lead us thinking about different ways plot could go. And also possible ways of modulating the ways in which we imagine plot, right? The ways in which we see these actual occurrences. And so one thought is these might be useful as a first step to capturing alternate worlds fiction, or these parallel possibilities of plot, which we can't really capture when we're just thinking about what actually happened. Okay, so that is the first part of this, and now I'm going to move on to the second part where I talk about information propagation. Okay, so here is now the second project on information propagation. This is joint work with David Banman again, and I'm just going to jump in. So here is Great Expectations, and this is a character network that we produce for Great Expectations. So here, nodes are characters. Edges are conversational interactions. So anytime there's an interaction between two characters, we draw an edge between them. And information is quoted speech. So something like Miss Havisham is dead. I hope I'm not giving too much away about Great Expectations. Hopefully you've read it. And so the goal here of this project is to try and find propagation through this network. So repetition of information across a character triad in this quoted speech. So what do I mean by that? So for instance, we have a character node represented by this green node that says Miss Havisham is dead. The yellow node, whatever character it happens to be, hears that and then says it again to a third character represented by blue. So we're trying to look not the identical information, but essentially, sorry, not the identical way of saying the information, but the identical information itself, right? So here, two different ways of saying Miss Havisham is dead being propagated through three characters. So this is essentially the goal of the project, and I'm talking about how we went about it and why it might be interesting. But before I do that, it's worth asking again, why fiction? Why is this relevant or interesting? So here's this quote from Charles Caduchin. Social network theory is one of the few theories in social science that can be applied to a variety of levels of analysis, from small groups to entire global systems. So while we can apply analysis to all kinds of different systems and all different scales, the reality is that in general, the scales that network analysis tends to apply to tend to be relatively big. So even this, which isn't a relatively large network, is still much larger than the average novel, right, as far as a network would be. So here, this is DH 2014 tweets, and the nodes are different handles on Twitter, and the ties are tweets mentioned on a user. We can see it tends to be pretty dense, right? There are lots of nodes, there's lots of connections between them. Similarly, here's another example, viral text sharing in newspapers, 19th century, and we see these are newspapers that had shared the same text in different across different publications. And we see even though there aren't actually that many nodes, the density of the network is very high. So lots and lots of connections. So compare these two different networks with something like Hamlet and Macbeth. So here, nodes are characters and edges are being drawn whenever two characters appear in the same scene. Obviously, this is a very different kind of network than the previous ones, right? Not very dense. We can see a network density at the bottom. So 39% in case of Hamlet and 25% in the case of Macbeth. Not many nodes, right? So a very different kind of approach you can imagine to try and understand propagation and information in this context as opposed to the other networks. Also, just looking at this, I think it's interesting as a side note that Hamlet is very much the center of the network Hamlet, right? The character Hamlet is at the center, whereas the character Macbeth is less so at the center of the network Macbeth, right? And we also have these other neighborhoods represented by the three witches that are coming off on the sides. So I'll come back to this later. I think it's interesting to look at. But before doing that, stepping back and thinking about kind of what is the other research in this kind of general domain of information diffusion and propagation. So there's been work in diffusion in blogs before sort of social media took off. And then as social media becomes more and more prevalent, we have the spread of rumor and misinformation. So for instance, work by Fragari and Del Vicario, thinking about how misinformation spreads. And then finally, textual reuse across different legislative bills, a very different kind of way of thinking about, right, how information might move across things, right? Legislative bills, totally different than misinformation, but still, right, relevant and interesting to think about how propagation might happen. That being said, all these things are very different from the literary context, and I'll briefly talk through the ways in which that's the case. So here, looking at these cascading behavior in large blog graphs, we see all these different kinds of shapes and nodes and ways of things being propagated. You can imagine a novel, there'd be far fewer different varieties of information moving across, right? There probably isn't this wide array of different things being passed through different kind of network shapes. Similarly, in this legislative work, right, looking at different legislative bills, often legislative bills are extremely similar, right? So here they're very minor differences. So essentially, all that's needed is textual alignment to find information propagation because the differences are so minute that for the most part, these long patches tend to be the same. It's very unlikely you'd see in a novel these very long passages in which things line up, right? Almost never would you see something like this. And then similarly, in this meme tracking and dynamics of the news cycle work, these are quotes from Sarah Palin, and don't worry, you probably can't read all of them now. But there are all these kind of slight paraphrases and variations on the same thing represented by these arrows. But for the most part, very, very close to right, the original thing that's being said. Unlike politicians, right, a novel, it's unlikely you'd have such slight variations between these different, between essentially the same piece of information, right? Things tend to be pretty different. Novelists try not to repeat themselves too much. So with all this in mind, we had to create a new pipeline for measuring propagation for this unique task in literature. And lots of different things go into this. So coreference resolution, which is right, matching all the characters up and creating right, a single kind of chain for each character. Speaker attribution, matching up the quotation with the actual speaker that spoke it. Identification of character networks themselves, which we saw a little bit with great rotations. Information extraction, what do we actually mean by information? How are we going to pull it out? And then finally, identifying propagation and network measures. So here, the actual thing we're trying to get at through all this is the network measures themselves, right? How do we distinguish kind of what makes propagation unique, what makes the character's propagation unique, what about the network is causing this to happen? So I'm just going to briefly go through all of these different aspects in the pipeline. The first being coreference resolution. We use the same approach as used by Bayman et al. 2019. So here we use a neural coreference system inspired by Lee et al. And we just augment that with BERT contextual representations. And this is trained on 80 literary books with a dev and test set of 10 books each. And this is all drawn from the LitBank data set. We find that the performance on PR entities, which is to say people, entities, right, persons, is in line with performance on ontonotes, which is the common thing that people tend to use as a data set for coreference tasks. So onto notes, right, 67.2 on overall entity types. We end up with an average of 68.1. So doing pretty well. Clearly, we can do decently with coreference on literature relative to previous approaches. As far as speaker attribution, we actually released a new data set and annotate it. This is the same hard text from LitBank. And here we're trying to match all the boundaries of true quotations with the speakers. And in order to do this, we also need, of course, to get the quotes themselves. And so we use BookNLP to get quote attribution. And it's worth just very briefly thinking about what are the kind of errors that occur when you try and identify quotes in literature. So things that come up are things like jargon. Every chancellor was in it for somebody or other when he was counsel at the bar. Neologisms like the Red Death. Irony, when his friends spoke of him, they usually said that he was at Geneva studying. So studying essentially in square quotes here. Titles of art, written use. So all kinds of kind of errors that come up. But for the most part, we do a pretty good job of actually identifying quotes. So once we have the quotes right, we have to actually do the speaker attribution itself. We implement the method of Musny et al., which uses 3 deterministic sleeves for mapping quotes to the nearest speaker mention. And so the 3 sleeves are first these kind of regular expressions, things like, quote mention verb patterns of, quote said some character, looking at the dependency structure and looking at some nominal subject relation between character and the verb of communicating. And finally, identifying vocatives in a previous quotation. So if in a previous quotation, right, someone is addressed in that quotation, that's a good sign that probably the next quotation is going to be attributed to them. So again, the same metrics we use for coreference. Here, each cluster is defined as a set of quotations spoken by the same speaker. And we do pretty well, 71.3. If we had access to the Oracle coreference labels, so the gold labels for coreference, we would do about 10% better on average. So improving coreference would definitely do a lot to improve speaker attribution as well. So that's a worthwhile thing probably to invest in the future. Okay, so we have our speakers and we have the quotations that they've spoken. Now we actually need to build a network. How are we going to go about doing this? And so there are a couple different ways to approach this. I'm not going to go through all of these because I see I'm running a little short on time, but of these 5 laid out by this work by Lebetud and Bose, we end up doing conversational interaction since it seems to make the most sense since we're talking about information propagation and also very easy, right, to capture conversational interaction. And so how do we actually do this? So imagine you have a block of text and you're going through it. And what we look for is 3 contiguous sentences in which there is no quoted speech. So here, the first one is 1 sentence. The next one is only 1 sentence too. So we continue looking for the end of this conversational block. And then finally, we get to 3 sentences or more in which there's no quoted speech. And so we end our conversational block here. And we pick out all the entities, all the character entities that take place in this block, and we just draw edges between them. So essentially, any time that we see characters in this conversational block, we would draw an edge between them in a single edge, but then weight this if we see multiple instances of the same character interacting with another character in another conversational block. Finally, actually a few more steps, but defining and extracting information. We go with this really kind of atomic way of thinking about information in which we have these propositional tuples of the form subject, verb, object, in which the verb has a nominal subject relation to either character entity, nominal phrase, or null token. And the same is true for the direct object relation. So this may not be super clear, but I'll look at an example, I'll show you an example. So for instance, the sentence Bob punched Tom and he left. We pull out 2 tuples, first Bob, punch, and Tom. So the 2 entities, Bob and Tom, and punch. And in the second case, Bob, leave, null, right? There's no character in that position for the direct object or anything else for the direct object, so it's be null. So we also limit our information to specific topics. This is partly to focus on things that are relevant to novels in general, but also to avoid false positives because there's a lot of noise going on here. And so topics focus are amorous, hostile, juridical, and vital. And the words associated with these, all these words show up in the top 100 tuples that we found across all these novels. We also select all various synonyms for these words as well. We find that 3.6 thousand of these 5,000 books contain repeated tuplets of one of these topics, and that 35% of those contain actual propagation. So 1,260 in total instances of actual propagation across all our novels. So I'm gonna step back in case that didn't make any sense and motivate us a little more. Again, why are we doing this? What's interesting about this? So I said the goal here is to see if we can find instances of propagation in which information is propagated from character A to character B to character C. What we're really interested in is this character B, right? This middle character that is actually doing the propagating. And so if we look at Hamlet again, right, if we think about Hamlet as this character, one can imagine one theory is that Hamlet tends to propagate information among close ties, right? This kind of very tightly connected network. Conversely, Macbeth, we might imagine that the kind of character that would propagate information would be this character here, whoever this character is, who's serving more based on their position in the network as a link to different neighborhoods. So instead of these kind of tightly connected connections, we have the character essentially serving as a bridge between these different neighborhoods. So that's kind of motivating research question. On the one hand, is it kind of gossip among close friends and family that leads to instances of propagation in novels, or is it these information bridges that are passing information between these otherwise disconnected communities? So in order to kind of highlight this more, even and as an illustrative example, we can look at propagation with the Tin Man and Scarecrow. So let's say, for instance, the Scarecrow says the Wicked Witch is dead. The Tin Man says the Wicked Witch is dead to the Scarecrow. And then the Scarecrow says, you'll never guess what happened to the Wicked Witch, she's dead, and tells this to Dorothy. Right, so here we have an instance of propagation. So here, indeed, we have propagated information from the Tin Man to the Scarecrow to Dorothy. Conversely, with the Lion, right, the Lion, let's imagine, was also present when the Tin Man said this, but didn't propagate information. And so in the Lion's case, we have the failure to propagate. And so these are going to be are two different kind of means of comparison. Nodes that are present, characters are present for something, but ones that propagate and ones that don't propagate. And so we're going to use a variety of network measures to kind of analyze these different nodes. So betweenness centrality, how many shortest paths between pairs of nodes pass through that node, closeness centrality, the inverse distance of the node to all other nodes. And again, I'm speaking of the specific B nodes. Average neighbor degree, so what's the average degree of the neighbors of that node? Effective size, which essentially is a measure of if we remove that node, how much of a structural hole would be created, which is say how tightly connected are the connections of that node to each other. Efficiency, which is just effective size divided by the node's degree. And finally, the number of triangles, the kind of triadic closure that the node serves as one of the edges of, one of the nodes of. And so in all, we have 1,730 of each of these. So again, nodes that were both present in which one actually propagated information and the other didn't. In order to analyze sort of, right, how these network features play out for each one, we just have this very kind of basic logistic regression model because it's highly interpretable, and we want to understand how are these different features playing out, and use this as a way to kind of contextualize these network dynamics. So what are the results? So we see that things like betweenness centrality and closeness centrality are not very important. Right? They have low model coefficients, and they are not, in fact, at a p-value of 0.01 significant, which is to say that we might imagine these things, right? If our first theory that information propagation tends to happen among very closely knit nodes, essentially in like instances of gossip, right, where everything is kind of all the characters are tightly knit together, right? If those were higher, we'd imagine that that would support that theory. But in fact, we seem to be claiming that the other theory is true because efficiency and average neighbor degree turn out to be the most important things. We're to say that efficiency, right, when a node serves essentially as an informational bridge and average neighbor degree, negatively correlated, right? So when the different nodes in a node's neighborhood, different carriages in a node's neighborhood are not really well connected themselves, these are when we actually see information propagation. So the second theory, right, that these characters in these novels, when they propagate information, they're doing so in a way in which they're serving as bridges between disconnected neighborhoods. So why is this interesting? This was kind of a unique and surprising result that we thought when we found it. And the reason why I think it's interesting is because this is actually what we find in the real world. So here's Mark Granovetter writing about the real world and the significance of weak ties. So weak ties then would be that those which are local bridges create more and shorter paths. The contention here is that removal of the average weak tie would do more damage to transmission probabilities than would that of the average strong one, right? So it turns out that in the real world, weak ties, these kind of ties in which disparate neighborhoods that aren't well connected, right, those are really important, right? And losing those would be kind of a major loss to the movement of information across the network. Indeed, that's what we find in novels too, that the characters that tend to move information are the ones that have these weak ties across these different neighborhoods, right? But they are also really the ones that are serving bridges. So in a sense, the dynamics of the novel, these network dynamics, are mirroring the dynamics of the real world. Okay, so in the last 5 minutes or so, I'm just gonna bring up something else, which is that this whole time I've been talking about implicit propagation, right? Instances in which we are actually finding propagation, but I've kind of ignored this whole other thing, right? Explicit propagation, right? Because very, very clearly there are instances in which someone says something like, Bob told me that Jack escaped. And by definition of propagation being the movement of information from character A to character B to character C, this is an instance of that, just explicitly. And so we also build a kind of very simple extraction way to pull out all of these. And we can do so, of course, with very high precision. And so we don't need to worry about informational topics. We don't have to limit ourselves to specific topics. And this yields roughly 90,000 instances of propagation. Compare that with the 1,730 used for implicit prop. So obviously, there are things we can do with this that we couldn't do previously. And so we choose to look at gender and think about how propagation and gender might play out in these novels. And so what we do is we analyze the relative proportion of different gender configurations for these propagating triads compared to all triads. So any triad that exists across all data set. And in order to determine gender, we just count up the number of pronouns associated with each gender in that character's coreference chain. So, right, he, him, etc. If there are lots of those, we can assume it's male. And so what do we find? So first we find that 15.4% of all character triads are comprised of 3 women. 21.1% of triads involve information propagation with 3 women. So, right, women seem to be propagating more in these cases than we would expect. The only conversion, in fact, in which a female character serves as a middle node and doesn't propagate more than we would expect is when a woman character is the middle node between 2 male characters. And generally find that a portion of information propagation when the middle node is male, in contrast to women or female characters, is lower than expected. So what does this all mean? Essentially, it means that relative to their expectation, women propagate information more comparatively than men in these novels, which don't know quite what that means yet, but it seems interesting, an interesting finding, and not quite sure how it relates to the real world, unlike the previous result we saw before, but seems suggestive somehow of the role that female characters are playing in these novels as far as moving information across networks, and in general, their roles in fiction. So that's generally what I want to talk about. Those are the 2 projects. Very briefly, I'll just mention some future research that we're considering. So one is improving coreference for these texts and also building a joint neural model for coreference and quote attribution. As I mentioned, improving coreference would have improved our quote attribution model substantially by about 10 percentage points. So we're thinking about how we might go about doing this. Another big thing, just generally in the fiction space, not relevant to the research I talked about today, but is figuring out ways to model empathy in fiction. This is a very interesting line of research. Empathy seems to be a really essential function of literature, which I think is maybe plays out differently in more kind of objective reporting like the news. And so figuring out ways to model this, I think, would be compelling. And finally, thinking about narrative more generally, so for instance, narrative in the context of screenplays, in which we have more structured information, and how we might build models that are similar, thinking about events and thinking about propagation, but in the context of that discourse. So thanks so much. That's all I wanted to say today. I hope that was interesting. And I noticed there are a few questions that I got in the chat, which I'll now address. Actually, I think probably hard to go back at this point. So maybe we'll just end there.
Sure. I mean, do you have trouble seeing the questions? Do you want me to read them out? I think the first one was from Vivek was referring back to the first project that you had presented on, and specifically was looking at that chart. I don't know if you can address it, but I think it was the ratio of real events per slice to total in each novel, or, and correct me Vivek if I'm wrong, or was it sort of at aggregate across all the novels that you were?
Okay, yes, that's per novel, yes. That is not an aggregate across everything, but for each novel individually, we're taking essentially the average ratio across all novels for each of those different classes.
Great. And then the second question, also from Vivek, which referred to the second project you were talking about. How are you joining characters that were addressed in 2 or more different ways? And I think this, correct me again if I'm wrong, Vivek, but I think this is sort of how you were determining the connections between nodes, in terms of, like, you know, you were saying they asked them, they you know, different verbs that would sort of draw a line between 2 nodes. If those were like sort of different, they sort of included 2 different interactions between two people, or described 2 different ways of interacting, I suppose would be more accurate.
So essentially, if I understand this right, this is how we're building these networks in which there are different interactions. So I'm not sure if I'm addressing this probably, but essentially, right, when we're trying to construct these networks, the only thing that we're really looking at is whether or not these characters are co-present. So we have previously from our quote attribution, right? For instance, so cried my sister, we know that the sister character, and we have their whole kind of co-reference chain for sister and all the references to sister were made. We know that the sister said this, right? And so as far as the characters that heard this, right, the characters that were present to hear this information, any character that we see that was in this conversational block, we assume was present. And so there are other ways to think that we could have done this, right? We could have thought about different kinds of interaction, but here we're just saying, okay, here's a conversational block. Someone said something, everyone else was present. Let's draw an edge between them. And if we see in a different conversational block, those characters are present again, then we just weight that edge between those 2 characters a little more. So that's general the approach. Is a little bit reductive. I think, Drew, is that your understanding of what the question was, or am I?
I think so. Vivek just actually clarified, how are 2 nodes found to be the same if they are the same characters but called 2 different names? So I guess an example would be like my sister versus actually referring to that sister by her proper name.
Right, I got it. Okay, sure. Thanks, Vivek. So that essentially is what the coreference resolution model is doing. So what coreference is doing is it is right, taking all these different references and figuring out kind of what's the chain of the same reference. So if you have a pronoun he, what he is that referring to? If you have John Smith and Mr. Smith, like figuring out those are the same character. And so we have, right, these single character entities. We have all these different references to them, and through coreference, we're figuring out, okay, which ones are the same. And again, right, that's the results we do pretty good. There's definitely room for improvement. That's right. I think I'm saying at the end, right, there 68.1 is decent here on average across these different metrics. These are kind of the common metrics that are used for coreference. But certainly improving that will help everything. And I think maybe what you're getting at too, right, is there are lots of different aspects of this pipeline. And so improving any aspect of the pipeline will be useful overall for the whole pipeline.
Great, thanks, Matthew. Rodrigo is asking, do you have baselines in which a book was hand labeled? And I'm not sure if they're referring to the co-referencing here or not. But I assume that you know, these are measured against something like that.
So for the, assuming you're referring to coreference, everything has been hand labeled for coreference. So this is all trained on hand labeled data for these A-literary books with the dev and test set of 10 books each. Right, so we have training. That being said, right, the books, we're just taking the first 2,000 words of each book. And so we haven't actually labeled an entire novel. Right, so you can imagine it probably useful for the kind of, since we're applying this to entire novels, it would be useful hypothetically to have hand annotated data for like the entire novel for 100 different novels. But it's just not feasible with the amount of time that would take at this point.
I have a question. Have you tried addressing, plots and events in works that, have a confusing way of unfolding or narrating plot, like things that are out of chronological order or sort of things that go through different viewpoints and perspectives in the narrative? Like I'm thinking of like The Sound and the Fury by Faulkner or something along those lines. Like as a reader, I kind of think that, to a certain degree, there's some there's some interest there. It's interesting. It's kind of like a puzzle. You really have to concentrate and read it over and over again to figure it out. But for purposes of analysis and specifically like what you're trying to do, what do they have any particular challenges? Is it completely different, or does it actually make no difference at all? Just kind of curious how you cover those types of work, or if you have tried to cover those types of work.
Yeah, I mean that's a great question. I think the dream is to eventually get there, right, where we can think about the real complexity of plot and narrative. Right, I titled this talk "How to Machine Read a Novel," but I think that's far more ambitious than where we're at right now. Right, that's the dream. Right now, right, for the purpose of something like Faulkner, right, for instance, or Joyce, it is hypothetically in some ways harder to pull events just because like the language is very complex and there's lots of metaphor and all that. But it's not fundamentally different when we're just pulling out events in these kind of simple binary ways than it would be from something like The Invisible Man. Conversely, I think to your point, Drew, that when we start thinking about really capturing plot and thinking about temporal ordering of plot and how right, event setting coreference, all these other tasks, those are the things in which something like something complicated, something postmodern, something Faulkner, or I see Alex in the chat mentioned Gravity's Rainbow. That's when these challenges really come up. And so yeah, until we finish all these tasks, I don't think we can even begin to tackle that. There is a book for anyone curious, Galatea 2.2 by Richard Powers, in which is a novel in which he's talking about building an AI system that can do just this. Essentially, it can pass undergraduate English reading exam. And so hopefully we'll get there soon. We'll actually realize that dream of fiction. Yeah.
Very interesting. Thanks so much for sharing your work, Matthew. It's been great. I really appreciate it.
My pleasure. Thanks so much, Drew, and everybody else for coming by.
Yeah, thanks everybody. Take care.